Okay, so let's first talk about finding x-intercepts of functions. Now, the way you think about x-intercepts, if you guys think about the graph of a function, right? If this is x to the 6, says x to the 6th power, how many times is this function going to cross the x-axis? 6 times. That's the idea, that the highest exponent, the degree, will tell you how many times. And you're going to find out later in this lesson that it won't always be exactly like that, because we're going to talk about double roots and triple roots that are going to add up to give you a total of 6. But just for our purposes right now, let's just say it's like this. That should be 6. 1, 2, 3, 4, 5, 6. Yes, everyone see that? So you'll notice on the x-axis, Peter, find a pen or a pencil. Stop using expo marker. On the x-axis, when we have x-intercepts, what are the y values for those? What are the y values for the x-intercepts? They're 0. So the way we're going to solve this is to set our y value equal to 0. What is our y value up in this problem? What is the same as the letter y? What in the problem is the same as the letter y? Not x. X is not the same as y. F of x is the same as y. So I'm going to write 0 equals x to the 6th minus 3x to the 4th power plus 2x squared. Now, how am I going to figure out what values for x are going to make that 0? Just going to plug in numbers, guess and check? What do you think is the most effective way? You've got on the right side we have a trinomial, so we're going to do what? We're going to factor. What do you notice about those 3 terms? They have an x squared in common, so let's factor that out. What happens when you factor out x squared? You have x to the 4th power minus 3x squared plus just 2. Right? The x squared is gone. It's been pulled out. All right? Now, I'm not going to do anything with the x squared in front. I'm going to leave that alone for now. This is something that you may or may not have seen in a previous algebra class. This, when you took algebra 1, was x squared, and this was just x. Do you remember how you factored that? You have like the 2 binomials. All right, we're going to do the same thing. We're going to do the same thing. But instead of x and x at the beginning of these binomials, what am I going to put at the beginning of the binomials? X squared and x squared. Because if I write x squared times x squared, what does x squared times x squared give me? X to the 4th power. So it's the same idea about what multiplies to give you 2 and adds to negative 3. We just have a little bit of a change with like the x squareds. All right, so let's think. What are 2 numbers that multiply to give you 2 and add to give you negative 3? Not negative 2 and 1. Negative 2 and negative 1, right? Because negative 2 times negative 1 is positive 2. And then what's negative 2 plus negative 1? Negative 3. So we have factored that. Let's bring down the x squared. Are we fully factored? Are we fully factored? Sylvester says no, but not confidently. Not confidently. But he's saying no. Does anyone see up here another one of these factors that we can break down even more? Oh, sad. And it's one of my favorite acronyms because it makes me think of my childhood. No, we don't remember what dots means. What did you say? No. What is it, Sylvester? Difference of 2 squares. Difference of 2 squares. Which one up here is the difference of 2 perfect squares? This one, x squared and 1 are both perfect squares. So that's going to factor to be x minus 1 times x plus 1. And then I'm going to bring down x squared minus 2. Why did I not do the same thing for x squared minus 2? It's subtraction. It's the difference. Because 2 is not a perfect square. All right, so that's why I didn't do that one. And then bring down x squared. Now we have fully factored. Let's make sure you guys still see we have x to the 6th power here. So that's 2. That's another 2. That's 4, right? That's 5. And there's 6. So we still have x to the 6th power. We just now have it broken up. All right? So what's going to make all these things 0? Let's switch colors to show you we're in a different area now. We have x squared is equal to 0. X squared minus 2 is equal to 0. X minus 1 is equal to 0. And x plus 1. All right, I think we can do the first and the last two pretty simply. What number squared gives you 0? 0. So this one's 0. What about these over here? X equals 1 and what about this one over here? Negative 1. All right, back to your days of algebra. Well, what about x squared minus 2? If I move that 2 over, I have x squared equals positive 2. How am I going to get rid of that square? The square root. Am I doing it? Did I draw that square root? I'm not trying to trick you. Did I just draw that square root? Yes. So the answer is x equals... Somebody said it. Plus or minus the square root of 2. So how many roots do I have? How many x-intercepts? Right? What? I thought we said it was going to be 6. Shouldn't it be 6? Why are there only 5 answers? 1, 2, 3, 4, 5. Why are there only 5? You told me 6. I mean, I told you 6. Why are there only 5? Do you see this one here? That came from x squared equals 0. So that is what we call a double root. So it counts as 2 roots. Even though it's only 1 root, like 1 answer, you think of it as 2 roots. So now in your brain you think this is 2, 3, 4, 5, 6. We've got 6. Everybody good there? That's called the multiplicity of a root. In this case, it's double multiplicity. Now, why did this not give us a double root? Right, because it's still x squared. That gave me how many roots? It gave me 2 roots. Positive square root of 2 and negative square root of 2. So that's 2 separate roots. All right, so don't think that's a double root. That's just 2 separate roots. They're different numbers. The answer is all of these. Because what are the x-intercepts? They're all of these. But I'm trying to show you, Jalissa, hopefully you see that there's not 6 answers. There's 5 because one of them is a double root. But it's always a good thing to check. What's the degree? That's how many answers I should have. So I have 1, 2, 3, 4, 5, but that's a double root, so that gives you that 6th. Any questions on this example? Now, do you guys want to see what the graph looks like? Here's what the graph looks like. So it's pretty much the same thing as we wrote, or drew, except, do you see it 0? You see how a double roots do not cross the axis, right? All these other roots cross the axis, but see here how it hits and comes back. It doesn't cross over the x-axis. So that's why you'll notice we only have 5. 1, 2, 3, 4, 5, even though it's to the 6th power. We'll talk more about that later in this class period. Questions? Now, here's what you're going to try. You're going to try these 2, but let's just take a look at this one. Any thoughts about how you're going to go about solving number 1? Yeah, Suzanne? Yes, parentheses, but what? Okay, there's a name that we used. There it is. You guys put it together. Factor by grouping. This is factor by grouping, so your brain's going to see if you can do that again. What about this one here, number 2? What do you see in number 2? See 3 terms again. How am I going to factor? How? What, Jalen? They all have what in common first? 1x. Take out that x, and then you should be able to continue factoring. Something you know how to do. All right? It's going to be your chance these 10 minutes to see if you remember how to do this. Yes, stand